Good morning, students. Today we shall begin a new chapter in physics. The name of the chapter is Sound. Today shall be the first part from this chapter. Let's begin today's topic by answering a question. What is sound? You have studied about different forms of energy. Sound is also a form of energy. But how to differentiate between any other form of energy and sound? So we may say that sound is a form of energy which produces a sensation of hearing in our ears. We know that we have different sense organs in our body, and one such sense organ is ear. So perception of any type of sound is possible due to the working of this particular sense organ. So sound is a form of energy that produces a sensation of hearing in our ears. So how is sound produced? We hear different sounds every day, such as the sound of an alarm clock, horn of a bus, school bell, doorbell, people shouting, talking, laughing. All these are common sounds that we listen almost every single day. But the basic question arises, how are all these sounds produced? Sound is produced by vibrating bodies. Our voice, that is talking, laughing, singing, shouting, crying, is produced by the vibrations of the vocal cords. Actually, we can feel the vibrations from the throat if we place our hand on the voice box, that is larynx. Similarly, vibrating membrane of a drum produces sound. Vibrating strings of a guitar produces music. A tuning fork, when tapped with an object, it vibrates to produce sound. If a vibrating tuning fork is brought near the ear, a sound is heard. Similarly, when a metal object is hit with any other object, like a very common thing, you can see that in a picture a child is hitting a pan with a stick, obviously sound will be heard. So all such sounds are possible due to vibrations. Whenever any object vibrates, it can produce a sound. Now whether it is going to be audible or not, that will depend upon the amplitude of vibrations. We shall be studying about it in the coming video lessons, but for this time you should know that it is not essential that whenever sound is produced it is audible, but whenever any object is vibrating it will produce sound. You can consider the example of several musical instruments. These are some common musical instruments that all of you have seen. In all these musical instruments, some part is vibrating, due to which it is producing sound. Say for example a drum, it is the membrane which is vibrating. In a dholak or a tabla, the membrane is vibrating. When the membrane of the tabla is hit by the hand, it starts vibrating. Now you might have seen that any person who knows how to play this instrument, they do a bit of adjustment. They ensure the extent to which this membrane is going to be tightened by adjusting. So that is going to decide the type of sound being produced. In any stringed instruments, the string is plucked either by the hand or by any suitable device, due to which the string starts vibrating and that produces sound. So be it a violin, guitar, sitar. In a flute, the air inside the flute is vibrating. Similarly, in a clarinet or a saxophone, air blown into the pipe is deciding. You can see a harmonium, it has got reeds. So when the reed is pressed and the amount of air that is changed by moving this part, that is responsible for creating the musical sound. So in all these musical instruments, vibrations are responsible for production of sound. So whenever this question is arised, what is the cause, what is the basic cause of all sounds, then you should say that vibrations are the cause, are the basic cause of all sounds. How does sound propagate? How does sound travel? You can see in this picture how the sound is traveling. This particular membrane is vibrating backward and forward. These vibrations are responsible for creating sound, and how these sounds are traveling in any medium. So the question is, how does sound propagate in any medium? The sound energy reaches the receiver through mechanical wave motion. This means the vibratory motion of the particles of the medium. Now let us understand this by a very common example. Let a stone be thrown into a pond. It will start ripples which will spread out in all directions on the surface of the water. The formation of ripples on the surface of water is a very good example of wave motion. Here, water is the medium of wave motion into the pond. The energy carried by the stone disturbs the water molecules close to it. By gaining the energy from the stone, the water molecules near the stone start vibrating up and down. They in turn produce similar motion in other neighboring particles. The particles of the medium do not move forward themselves, but the disturbance is carried forward. Wave motion is a disturbance produced in a vibratory medium that travels from one point to another point, involving the transfer of energy but not the transfer of any matter of the medium with it. So when an object vibrates, it sets the particles of the medium around the object onto vibrations. These vibrating particles exert a force on the adjacent particles of the medium. This makes the adjacent particles displace from their mean position. These displaced vibrating particles further disturb the adjacent particles. This process continues till the sound reaches our ears. The vibrating particles transfer some of the energy of the adjacent particles, which also start vibrating, and so on. So in this way, a wave is formed. So wave is a disturbance that continues in a medium when the particles of the medium set the neighboring particles into motion. So it is the disturbance created by the source of sound in a medium that propagates in the medium, and not the particles of the medium. Now here I would like to tell you a couple of things. The speed of sound wave depends upon the nature of the medium through which it travels. The sound wave at a uniform speed in all directions in a medium. The medium does not move as a whole during sound wave motion. The particles of the medium do not move from one place to another. They only vibrate about their fixed positions, disturbing adjacent particles. Sound wave motion is possible in the elastic and continuous medium. Now, whenever sound is generated, the sound travels in the medium in the form of compressions and rarefactions. There is a change in the density of the particles of the medium whenever the sound wave is moving from one part to the other part of the medium. So, the portion of the medium where the density of the particles has increased is called a compression, where the density of the particles has increased from the normal. Alternately, there is a region formed where the density of the particle has decreased than the normal. That region is called a rarefaction. So, alternately we have compression and rarefaction. As you can see, the compression is represented by the up part, elevated part, and the rarefaction is shown by the depressed part. So, how compressions and rarefactions are formed and how sound propagates through a medium shall be the topic of discussion in the coming video lesson, where we shall classify sound as to what type of waves are sound, how do these waves travel in a medium, what are the basic characteristics, how we can represent them graphically. All these things will be discussed in the coming video lesson. Thank you.